Hi everyone. Today we'll be doing question 124 on LeetCode. It's called binary tree maximum path sum. A prerequisite for this question would be diameter of binary tree. So if you haven't done that one yet, please do that one first. But the reason why we're going to use that question, this one, is because in diameter of binary tree, we basically wanted to find the greatest height or slash width of the binary tree. And this time we're just going to be doing the same thing, except every single time we make a recursive call, instead of adding 1, we'll be adding the node value. So let's get started. Let's write our result, which is going to be starting at negative infinity. The reason why we choose negative infinity and not 0 as our starting point is because we can have a negative sum as our result. Cool. So moving on, let's write our function now. I'm going to start out by running out the diameter of binary tree recursive call first. So, as I mentioned before, this is just how you find the diameter of a binary tree. But instead of adding 1 every single time, we're instead going to be adding the node value to add on to our current path sum. Furthermore, because we can have a negative subtree sum, we want to ignore those that might have a negative sum. So how do we do that? We can just, at this line, compare the current left tree sum with 0. So if it's a less than 0 or negative sum in a certain subtree, then we basically ignore it. Same thing with the right subtree. And finally here, realize that left plus right substantiates the sum of the left and right subtrees, but it doesn't add on the current node that we're at. So for example, if we're at 1, left plus right here returns 2 plus 3, which is 5. But we know that we need to include the root node of 1 here. So we need to add on plus the current node of that. Cool, and that's it. So let's call this and return the result. See if this works. Works just fine. And works just fine. Runtime of this, we're just DFSing through every single node. So this is going to be just O of n, where n is in, number of nodes in our binary tree. Cool. And that's about it. So with that, I'll put a link to the question as well as my GitHub down below. And I'll see you guys next time.